Cool. Hi, I've got a bit of echo. Thank you everyone for joining. My name's Billy Michael. I lead up our DevOps practice for Global Logic in the UK. Today we're here to talk about Crossplane. I guess a bit of background about how that came about. So we've probably over the past kind of 9 to 12 months been building our own internal platform here within Global Logic, as well as obviously helping some of our customers with their developer experience and internal developer platform challenges. That's gone through a few iterations. So we started off with using Terraform Cloud as a kind of orchestration layer within that platform, and we've more recently been looking at how Crossplane can be used as an orchestration layer to kind of really sit in the middle of your internal developer platform and orchestrate things like your developers' requests to create databases or bucket storage or something like that. That's really it from me. I'm going to hand over to my colleague who's going to be going through the playground today. So over to Michael.
I don't know if I'm live yet or not. Okay, hey everybody. We just need just a second to hook in my laptop, I'm afraid, but we'll be right with you. Yeah. Oh, this poor thing's gone to sleep. If it just is plug this in and it goes, then that'll be fine. Okay, lovely. Right, here's the DevOps Playground website. That's not what I want to show you, though. And, oh my goodness, there's one more thing I need to set up, sorry. How will we now?
Oh, okay.
There we go. Okay, right, apologies. Started in the wrong place. Here we go. So, Crossplane. Thanks, Billy, for the introduction. I'm here to give you a bit of an overview and introduction into Crossplane. We're going to go through some really basic overview, and then we're going to practice making, sorry, it's a bit of a sound problem. We're going to practice making some resources with Crossplane as two different personas on kind of either side of a DevOps or an internal developer platform. So, introduction. What is Crossplane? Crossplane is a tool for provisioning infrastructure, a little bit like Terraform, although I need to be careful how we compare them because they're not the same, but leveraging the Kubernetes API and using Kubernetes objects to interact with your infrastructure. So if you imagine with something like Terraform, you might create a declarative configuration and then run a tool over it, like again Terraform, to communicate with some cloud provider or some infrastructure provider, and then it results in some resources being created. This is the same, but we're going to do all of our interactions through Kubernetes completely, and Crossplane will sort of be the mediator for us. So you can think of it as Terraform, but via the Kubernetes API, but be careful because it's not exactly the same. Crossplane supports all sorts of cloud providers and other infrastructure providers that aren't just clouds. You can interact directly with databases if you have the connection to them. You can interact with Kubernetes itself. To keep things simple, we're just using AWS today, but like I said, if you go on the Crossplane marketplace or the Upbound marketplace, you can find lots and lots of different providers. What are the benefits of Crossplane? Well, sort of already covered these, but the biggest one is that you can manage both your infrastructure and your applications in Kubernetes, provided they're Kubernetes based, of course. But you know, if you're using Kubernetes, it's a good match. The other benefits that I've written here are essentially the same as most declarative configuration tools. You want to be able to abstract away some of the details of your infrastructure. And what we're doing today involves trying to remove some of the friction from the process of provisioning infrastructure for our application owners, or as I've called them today, application developers. When should we use Crossplane? Well, if we want to use Kubernetes for everything, it's obviously that's going to be a massive pro. If you're going to manage multi-cloud environments, persuasive argument that it is slightly easier than some other tools, and wow, that's repeating myself, isn't it? It's basically it's really good if you use Kubernetes for everything. I know that's not enough information to really get anything out of it, but we're going to go into a demo and I'm going to keep talking while we do stuff. So, I said we would be using 2 roles today. We're going to have a platform engineer and an application developer. The platform engineer is going to define some templates and some Kubernetes objects that the end users, in this case our application developer, can use to provision infrastructure. The platform engineer's concerns are kind of repeatability and consistency. They want to make it easier for those developers, but they also want the end users to easily match their organizational policies or just best practices. The end users need something they can consume as frictionlessly, it's a bad word, as easily and as smoothly as possible. They just want their resources, they just want their infrastructure, they don't need to deal with the details. They don't want to hear that, oh, well, you know, actually you forgot this really specific parameter that you don't really care about, but we need it for organizational reasons. They just want to get their infrastructure. So, sorry, I keep saying that. In slightly more detail, we're going to come back to this. We're going to specifically make an S3 bucket and a Postgres database. We're going to try and maintain some good standards by doing that. Although I've tried to keep it as light as possible, otherwise the configurations we're writing, especially for first-time users, can get quite verbose, and they're a little bit odd to look at until you've had a bit of experience with them. The same for an application developer. We're going to basically consume the things we made as a platform engineer, and thank you, and hopefully we'll see them created. If we don't, we'll learn how to troubleshoot them. And then we'll tear it all down. One more thing before we move to real practical. This is a diagram that I appreciate won't make much sense until the end of the session today. I hope it will make sense by the end of the session today. And it helps me at least demonstrate the sort of delineation between what the app team cares about, or what the app developers care about, and what the platform engineers care about. In Kubernetes specific speech, actually, hands up in the light audience as it is, hands up in the audience who feels they're really strong with Kubernetes. 1, not convinced. Okay, hands up who's used Kubernetes before. Not even convinced of that, okay. And hands up who has never used Kubernetes. You can, I don't know if you can type in the stream chat and say, you're like, oh yeah, I've never used it before, or oh yeah, I'm a huge pro with it. So in the Kubernetes sense, essentially everything the platform team does is not namespaced. Everything the app team does, or the app developers do, is namespaced. And that means that our end users don't have to see all this complexity. They can just get on with their work, and the platform engineers get all of the details they need to access without having to navigate around different structures. It sounds complicated, but it's neat. And again, I appreciate this diagram doesn't make sense until we've worked through it a little bit. So, to get started on real practical stuff. We've provisioned some infrastructure for everybody. If you are watching this later, this might not be available. This won't be available, at least not for this particular playground. So head on over to this address. I'm not going to read it out. If you sign in with your meetup username or your name, just something that's kind of guaranteed to be unique, you'll be granted an instance and some infrastructure to work with. I'll give everybody a moment to do that. Leave this up for a second and grab another drink because I'm already getting hoarse. I think this is empty. Maybe my microphone works. Double check. I'm looking for, oh, there it is. Hello, right. Hopefully most people, if not everyone, has had a chance to sign into our lab's website. You will be presented with a username, a password, and 3 links. And I would like you to open all 3 of those links in your browser. If you can open them without a browser, good job, I guess, but you get my one. I'm going to kill this, and we're going to go over to the main README in the DevOps Playground Crossplane repo. Now that might be a bit hard to read on the screen. I might change it to day mode. Although I don't do that very much, so I don't remember how to do it quickly. They say it's fine. I don't believe them, but okay. Right. I should trust the team that's helping us run this because they're very good. We're going to create some infrastructure in Kubernetes. If you don't know Kubernetes commands, don't worry. I've given you all of the commands that you need to run, and although I'm not going to teach everybody exactly how they work, it should be easy enough to follow, even if you don't understand them as you type them, or copy paste them as the case may be. Really important. Let me zoom in even more. Really important. Inside your terminal, which will look like this when you get one. Well, it won't if you didn't refresh it first. You will be signed in, sorry. My fingers worked while I was talking. You will be signed in the home directory of your user playground, and there is a workdir directory we need to go into. Inside this directory, before you drop into the repo, which is DevOps Playground Crossplane, we need to run this EKS config script. It's very simple. I'm not going to go into what it does in any detail. Suffice to say, it connects you to our Kubernetes cluster so that you can start using kubectl commands. We have a couple of tools installed that we're going to use today. We've got kubectl, which we'll be typing an awful lot. curious, that's what it looks like. And we've also got Helm, that's there. And I'm pretty sure that's it. There is a secret third tool, but I'm not telling you about that until the end. It's good. Inside the repo, there are folders that look like these. They are numbered and lettered in order, and we're going to step through each directory as we go. It's not critical for most stuff, but for some things you'll need the files that are in the right folder. Also, if you clicked all the links, you will be presented with, oh, I just closed it, that was brave. You're presented with a screen like this, which is VS Code. There's one thing to be aware of in this, and that is that if you create files in here, they will be owned by root. If anybody gets stuck with that, you can type in the chat, raise your hand if you're in the audience, and we'll try and help you out. But basically, if you need to create files, try and create them in here by writing this command, touch myfile.yaml, and it'll create a file for you to edit. Any other business here? Please don't use the terminal inside this editor. It doesn't have access to the same things as the wetty terminal here. So use this big black and white screen. Don't use this one unless you're editing files. Cool, right. Without further ado then, we're going to drop down into the platform engineer role. This whole thing's driven by README. So if you're stuck or you're not sure where we are, just open up a README. So, as a reminder, the platform engineer role, we need to make some S3 and Postgres resources available to our end users. We want to make them as easy as possible to consume, but we want the users to follow our policies without having to tell them. That doesn't mean we want to make it a secret. We just want to make sure that everything is as correct and easy as possible at the same time. So, to start with, dropping into 1A Crossplane install, we're going to install Crossplane. This is super easy. We go through some Helm-specific stuff. Suffice to say, we need these 3 commands, which you can copy with this button at the top right. And you can smash those straight into your terminal in any particular folder. One more thing, if you get stuck with pasting into the terminal here and it looks like this, that's because copy-paste doesn't work properly. It's an artifact of our really cool web terminal. Just right-click and hit paste, and then hit enter. On my instance, because I keep forgetting this, I've already installed a bunch of stuff, so you won't get this error. You'll get output that looks like this, which is why I have a README with all of the output in already. Give everybody a few seconds to run that command, and we'll move swiftly on.
Actually, you just did. I'll just follow. I'll do that afterwards.
Okay, audience looks good over here. So, time's up, internet. If you want to, you can verify that Crossplane is running by hitting kubectl get pods. You can just copy and paste that straight in. That just checks if there are any Crossplane. How do I even describe that in a non-Kubernetes way? I guess any Crossplane containers running in the system. Once that's complete, that's it. Crossplane's installed. We're going to go on to installing some providers. So providers in Crossplane, much like insert infrastructure as code tool here, are the way that you interface with some specific, I always said provider again, technology. So whether that's a cloud like AWS or a specific database server or Kubernetes itself, you would need to install the provider for that, that technology before you can interact with it at all using Crossplane. Crossplane itself doesn't come with any providers, not installed by default, and that just allows us to pick and choose the providers that we need, rather than having them all running when we don't really need them. So here we are. We've got this file in your other terminal. We've got this file, provider aws.yaml. It's pretty simple, especially by Kubernetes standards. If you're not used to Kubernetes, these 3 lines won't mean much. Or these 3 lines, sorry. But suffice to say, we are creating a Crossplane resource of kind provider, or a Crossplane provided resource that will install the S3, AWS S3, provider for us. The reason this file is structured this way is kind of out of scope for this, but it just is. And we need to also install the RDS provider, otherwise we won't be able to interact with RDS. I probably didn't say that yet. The database we're creating is an RDS database, or an RDS instance. So we can apply that file straight away. You can just type kubectl apply, don't forget this -f, and it will, and then the file name, and it will install that provider to your cluster. After a moment, it's our good old friend eventual consistency, after a moment, the resources and the types and the custom objects in Kubernetes will become available. It's not instant. If you want to check which providers are installed, you can type this command in, or you can paste it in like that, and you'll see, hey, I've got more than one provider installed. In fact, I've got 3 providers installed, and you might notice you will have 2 providers at least once you've installed the S3 provider. If I expand this little section, you can expand these too. They're not hidden; they're just there, little rollouts. It's also installed the AWS, or the family AWS provider. We're going to come back to that later because it's really useful, but it just gets installed magically. You haven't made a mistake. It's far too hot today. So we need to add that RDS provider to what we're doing. We can add another YAML document in this file. Apologies if I'm jumping around too much. By typing 3 dashes like this, and then starting to write. If you're as lazy as I am, which you should be, you should copy this whole thing and just paste a whole copy of it, and then we're going to edit it to make sense. So I like comments. We're going to call this RDS provider. Then we're going to go down here and rename this RDS. Then we're going to change these 3 characters. Oh, sorry, not those 2 characters. Ooh, careful. These 2 characters to RDS, because I happen to know that that's correct. Oops. Clean up and save it. If you want an example to quickly copy and paste, there's another example in that nice little rollout thing there. And you can just grab it and paste it in. It'll be correct. Or if you're afraid of making spelling mistakes. Once that's done, we are going to just apply the same file again. So I'm going up the list and I don't need to do that. Hey, I didn't switch directory because I was busy presenting. So we should be in 1B providers, just to be clear. And then we kubectl apply -f provider aws.yaml. Boom. You should see yours output will be subtly different from that, but it will say something about provider S3 and provider RDS. We're going to move on, even though you might not have finished that, because the next step is almost as simple and it's easy to catch up in this particular section. Once we've got some providers installed, and if you want to double check, again, you can check kubectl get providers, and it will tell you, hey, you know, you got RDS, you got S3, you got family AWS. We aren't done with providers yet. We've installed all the ones we need, but at the moment, they are just ready to do stuff, but they don't know how to communicate with our particular AWS instance. You have all been provided with credentials to access AWS. They're in a file called AWS creds. If I go up enough directories, they're here. You don't need to use these specifically, but FYI, that's those credentials. You can steal mine. Please don't steal mine, but it'll be fine if you do. What we're going to do here is tell the AWS family provider that there is credentials in a Kubernetes secret. And we've already done the work for you to put that file that I just showed into Kubernetes with your credentials in, not mine. So we're just telling the provider, hey, or providers, hey, this secret over here, this contains your AWS credentials. When you need them, look in here and it will just work. we need to fix that file though, so I shouldn't highlight it. Click the copy button, pop over to AWS config over here, and smash that in and save it. That's just a file on our system at the moment. It's not in Kubernetes, so you guessed it, we have to kubectl apply that file. We're going to be doing this a lot today because that's how you interact with Kubernetes. Cool. Okay, again, you'll have subtly different output because I've already done all this, and it's saying for me there's nothing to do. For you, it should say created. If there's a problem, shout us out in the chat, put your hand up in the audience, look me dead in the eye and say, this is wrong. So, we've applied 2 providers, we've resourced in 3 providers, we've configured 1 provider, which is configuring every provider, although as we find out, we have to tell it to do that later. I will give you all a minute to finish this one off, and we'll move on to composite resource definitions. Let me scroll up a little bit and leave this on this page. Is our audience well ahead? Of course they are. I just want to help. Okay, that is going to have to be enough time. So, moving on, you can use the links at the bottom of your README file. To composite resource definitions, here is where things start to get a little bit more complicated. Because all we've done so far is take some single-digit line YAML files-ish, close to, and apply them. Now we need to apply something that's a bit more complicated, a bit more verbose. I need to talk to you a little bit about XRDs and compositions. And incidentally, also XRs are coming up in a minute, but they're different, just to be confusing. Kubernetes already has this concept of a CRD, which is why composite resource definitions, which would be CRD, aren't called that in Crossplane. There might be other reasons, but as far as I've been able to guess. A composite resource definition is a representation of some custom Kubernetes objects that you will be able to create for yourself in a minute. So, depending on your experience with Kubernetes, you may be used to the idea of using lots of custom objects, you may not be. We are going to effectively, well actually, tell Kubernetes that we want to create some custom objects, and we're going to do it via this Crossplane XRD object. The XRD, well, the first XRD we're going to look at is an RDS one. I'm going to be careful how I scroll down. So if you pop over to the folder for this particular exercise, that's 1 dash blah 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 1C XRDs. You can see it on the left here. And open up the RDS XRD file, YAML file. I'll do it over here for you. We can see, let me close my other ones down, we don't need those. We can see that it is not as long as I promised. That's because I've cheated and taken some text out. And we're just going to step through what this defines. So there's quote-unquote normal Kubernetes stuff here. The API version and kind are things defined by Crossplane. They're not defined by our providers. They're defined by Crossplane. I'm going to skip this for a second. Then we define our own API, which I think is pretty cool. I've called ours, all of yours, panda.io. You can change this. This can be, this group line here, line 7, can be any string reasonably, but if you do, you will have to follow that change through a great many other small changes. So that's on you. If you want to do that, you can, just it'll become complicated. I'm sure you can manage, but be careful. So that group is the API group for our custom objects that we're going to implicitly create. It's important that this, well, it's not important, that's not the right word. It is neat, it is useful if this group is the same between a few of your XRDs where it makes sense. Or at least, maybe you have rds.panda.io and then some others can be s3.panda.io. It is just useful to understand them as a human if you can look at things and see, oh, they're obviously grouped together because they're named similarly. I'm going to keep it simple, I'm going to leave it at panda.io. I implore you to do the same. It's up to you. We're going to define two kinds of custom object here. We're going to define a kind of composition. I'll come back to that word in a second. And we're going to define a kind of claim, which we will come to much later. Not too much later, this isn't that long a demo, but you get my point. By convention, we name the composition kind with an X in the front, and the claim kind with a, sorry, I suppose I'm technically wrong there, it's a composite resource. We'll get back to it. The composition type with an X in the front, and the claim kind without an X, but otherwise the same. So you can see if I highlight this, it highlights this apart from the X. This plural should be, for human reasons, the same as your kind, but lowercase and with an S at the end. Unless your language, or English in this case, makes sense to respell the word, I wouldn't worry about it too much. This is just the pluralized form of this, otherwise it doesn't mean anything. It's to make the CLI useful to use. You might be able to see another highlight as I select this. That is because the name that we skipped over must be a concatenation of the plural form of your line 10 down here and the group name with a dot in between. If it doesn't say that, if it doesn't say plural dot group, this won't work. It will reject your XRD when you deploy it, and you'll have to spend 2 minutes fixing it. So, moving swiftly on, this is the simple part of this file. There's, it's not too complicated, there's a bit more basically. So, we're going to just take this whole bit of text here, and we're going to paste it instead of the versions key. Oh, sorry, my mouse has disappeared. The versions key here. I know that's a bit awkward, I'm very sorry. It should, you see mine hasn't. If it doesn't indent properly, you need to highlight everything below versions and indent it like that so that the dash is in line with the V and everything else is inside that dash. Nothing should be further left to it. To quickly whiz through this, in not too much detail, we're essentially defining a Kubernetes object with some special properties that we choose. So stuff up here, it's less flexible. You kind of have to specify most of these things. We're going to have a spec on that object because I'm not sure if that's by convention or by rules that has to have a spec, but it should do anyway. We describe what that spec field is for, and then we go down and we add a parameters block to the spec. And we are going to see where this comes out later in detail, but it's the claim, basically. This is the parameters we want our end users to specify on their claim in order to make resources. And we want them to give us a parameters block. I can explain why we've installed that, why we've added that. It seems useless here. Promise it's not. A parameters block, and under parameters, they need to specify panda name, special for DevOps Playground, instance size, and storage. You can see they have different types. Storage has an integer, the others are strings. They're simple parameters. There's not much else going on there. We also pick that all three of those have to be there, otherwise if someone creates an object based on this, it'll get rejected by the Kubernetes API. That's neat. For people who are used to using Kubernetes, those error messages will make sense. For people who are not using Kubernetes, if you make an object and it doesn't match this spec and you get an error message, it might be a bit bewildering, but I promise you it is, it makes sense in Kubernetes land. We also say the parameters block is required because you have to get the other things to be required. Easy peasy. Okay, once you've saved that, and if you're happy about the indentation, pop back to the README. It's a very long block. If you need a quick copy paste because the indentation isn't working, there's another one hidden there. You can just copy paste that stick it straight in. We're just going to deploy this. It's kubectl apply -f, that file name again. So I'm going to do that on my terminal. I'll double check that I saved it. Make sure I'm in the right directory. Oh, too many U's. Apply -f. What do we call this? RDS xrd.yaml go. If you get any errors, feel free to just grab the full version and put it straight in. Don't fret about trying to debug it carefully because it will take you a long time. It might take you a long time. That's not fair. I'm sorry. Okay. Now we've installed something more than just a provider. We can go and poke it to see what it can give us. So we can type kubectl explain. Explain can tell you about objects and APIs in Kubernetes, which is really useful. And I need to reference this because I just need to double check it. PostgreSQL instance.spec.parameters. If you're curious what that matches, scroll. That matches the claim kind, which is the type of the claim that we can make. So we want to know if our XRD deployed properly. We can just do kubectl get composite resource definitions. There's no way to call that XRD at the same time, I'm afraid, so it's got to use the long name. And you can see that I've got two because I already deployed a second one. But we can also, we can also paste in kubectl explain. So explaining the claim kind, and then we specifically want to look at the spec and the parameters, or the parameters field of the spec field of the object. If that's a bit confusing, please don't worry about it. The output is very neat. It's going to tell you the parameters that you have to specify to get your claim to work. I think I might pop back to the diagram very quickly because it will help bring it together. I say back to the diagram. It's in the presentation. Here it is. So very quickly while we're here, we are down in this layer defining this thing. I could do it with the mouse. We are down in this layer. We're defining this thing over here. We are talking a lot about this because the composite resource definition defines what a claim can be. But to be clear, we're doing this thing right now, and we're also, in a moment, going to go over and define some of these. Okay, just to bring that back. So, later on, we're going to come back to this. If I show you for just a moment, you don't need to do this yourselves, what it looks like when you don't define the subfields that we want, then that was so subtle that nod, I bet you didn't even see it. Then we get something that isn't particularly useful, right? Certainly not for the end user. So, like, oh, cool, the object we've described needs a metadata block and a spec block. What does that mean? Well, that's just everything in Kubernetes has those. TM. If we hit recursive as well, which is a useful command, we get loads more data, but now it's too much. Now I can't read this quickly. I have to really dig to be like, oh my God, okay, the thing we want is here. And it doesn't even give the descriptions. Rubbish. We like this version. Specifically, give us the parameters we need to specify, and that is all we need to care about. We are going to do this again near the end. Okie dokie. I closed my README. Good job. Scroll. We are down here. Right, compositions. Remember that diagram for a second. We've done one side of it. We're going to do the other side of it. Then we're going to publish those. Then we're going to bring them together with one of those claim objects. So, compositions. This is where, I know I almost said this essentially already, but this is where the real meat of it is. You haven't seen us define any resources yet. We've just talked about parameters for claims, whatever those are, and Kubernetes custom objects. This is where we do the work. So if I pop back to Oh, I've got it in here, sorry, I don't need to do that. If we open up the RDS composition, I'm focusing on RDS right now because I think it's slightly simpler. We're going to take a brief look at the S3 one when we're done with this, and then we'll deploy everything. So the RDS composition, again, I need a sip, oh, goodness me. Once again, this is another cross-plane object, a composition. Our XRD, our composite resource definition, this trips me up every time, is another kind of cross-plane custom object, or Kubernetes custom object from Crossplane, that defines its own custom objects. This one is going to reference some of those custom objects. So we give it a name. To my knowledge, this name does not have to be exactly like this. It's not got the same rules around it that the name of the composite resource definition has, but, sorry, the XRD has. But again, by convention, we choose it to be the plural of the kind we defined in the XRD. So X something. I've slipped in .aws here because it looks nice. I don't think it matters. It might do, and I could be mistaken. Please correct me if I'm wrong. If we scroll down a touch, we're going to skip over some of this stuff and come back to it in a moment. The composite type reference here is how we choose specifically, how we tell Kubernetes and Crossplane which XRD we're depending on. Or really, even better than that, what kind of composite resource to create, which is what we defined in the XRD. So remember, in the XRD, we didn't define a composition. We defined this thing, which is a composite resource. We're going to tell Crossplane, we want one of those, please. And also, that's going to contain these resources. That helps us bring in the parameters from the end user and apply them to whatever resources we write in here. So in this file, in this composition, we only have one resource. It's just an RDS instance. This has some obvious parts. It looks like a lot to start with, but I promise it's not. It has a base. The base is the thing that we're going to template, basically. So if we need to provide things here that are hard-coded, that the users can't change, or that we don't change based on the user's inputs somehow, then we hard-code them here. If we're going to bring the values for something here in from the outside somehow, more often than not, we don't specify it here, and it can look a bit confusing. Sometimes it's better to write in templates here, but most of the time it's better just to leave it out, make it clean and clear. The for provider block here, the provider config ref block here, names our provider config that we made almost at the beginning, which I understand might feel a long time ago now. We call it AWS. If you changed it, make sure you change this. For provider is much more familiar if you're used to some kind of infrastructure as code tools. These are the parameters for this kind of resource, in this case, an RDS instance. RDS instances need a number of parameters. They're not all necessarily like absolutely mandatory, but we've decided on these for this particular demo. Some of them you don't need to worry about. All of them, in fact, you don't need to worry about because we're not going to touch any of them. The patches section down here is a bit more interesting. Now, they're not intuitive when you first see them. If you go and look at the documentation, read through it, look through a couple of examples, they start to become a bit clearer. They are essentially taking fields from some place, that's the reason I say that, and putting them in some other place. Most of the time, they're taking fields from the composite resource, which has fields from the claim in it, and they're applying those fields to resources, optionally with some transformations or not. There's the example of a transformation down there where we add a dash to the end and then set which particular field it goes to. This one in particular, remember that parameters block we created? This one takes the panda name parameter from the well, it's implicitly from the claim, but it's really from the composite resource, and applies it to the applies it to the RDS instances for provider identifier prefix parameter field. You can go the other way as well. It's possible to take fields from resources and put them on the composite resource. That is useful because you can generate kind of chains of logic there, where one thing is applied, you get an ID out of it, you put that on the higher level object, another resource can't be created until it has the ID, so it pulls it down from the composite object above, and then it goes on like that. If you're very sharp, you might realize that that can't happen in one step. You're right, it is eventually consistent. That means it doesn't happen immediately, it happens eventually. Can be a bit frustrating, especially when you're in a rush trying to build a DevOps Playground. It's not too bad. Sometimes you just have to wait a little bit. Did I skip anything in there? Sorry. We skipped one thing about, right, there's a connection secrets system. So when you create some resources, they come with some information about how to use that resource. In the case of a database, it's things like the admin password and the admin user and the endpoint. Really important to your end users, really important to you. Crossplane wants to save all of those values, whether or not your users need them. So we here specify to put the connection secrets object in the Crossplane system namespace, which is more the platform engineering side than the user side. The users won't be able to see the Crossplane system namespace, most likely. Later on, we've got this password secret that we also create, and that puts the password secret, into the Crossplane system namespace as well. I've done that, not really perfect, I've done that to hide it because it makes it a bit cleaner at the end when we look at secrets, and it's confusing to have 3 secrets all contain the same information. There is a third secret here that isn't obvious because it's created using only using patches, and that is this, that comes from this write connection secret to ref field, where we set the namespace here, and I think the name as well. So it's this line here and here. I will come out of the weeds in this in just a second. I appreciate this is a bit odd. And that goes to the user's namespace where they created the claim. So ultimately, when we create claims in a minute, we should see secrets created where we created that claim. Come back to that. Okay, moving rapidly on. We're going to take this RDS composition. I think that it's already provided for you. I will double check in its entirety with no changes required because we'd be here all day. And we're going to apply it along with the S3 composition. I might have discovered a problem there. Did we apply the S3 XRD? I don't think we did. Okay. We're going to apply all of them. If we scroll down a little touch. Basically, you can steal these commands and run them. The only thing you need to know about this that's weird is you need to apply both of the XRDs before you can apply the compositions. You can apply them both at the same time, but it won't work. You'll have to just reapply until their XRDs are noticed by Kubernetes. The Kubernetes API or the Kubernetes system ends up creating the custom resources or custom resource definitions that you need, and the compositions will then be able to be deployed. Again, it doesn't take one step. It's not instant. It's our old friend, eventual consistency. I need a new sip. While you run that command, I'm going to distract you by looking at some things in the S3 composition. So get that applying. There isn't much different about our S3 composition. It uses a different composite type ref because we have a different XRD for S3 private buckets that we wanted to create. This is a bit more fun. It's got 3 resources in it rather than 1, so it's just slightly more interesting. That means we get to use not just patches, which are per resource, but we've created a patch set that I've called common. It's very unoriginal, sorry. That common patch set takes the region parameter from the from the private bucket claim that we will come to create, and it applies it to the region of every resource here. Every resource that has the patch set applied, which happens to be every resource. It doesn't do any clever transformations. It is just a keeping things dry type thing where I didn't want to write a patch on every resource that was identical, so we use a patch set to apply to all of them. You can see where the patch sets are applied. Under patches, you just have a patch of type patch set, and you give it the name. That's it. That could contain 100 patches if you wanted to. Don't quote me on that. There might be limits that I don't know about. But it can contain more than one, basically. Everything else is mostly similar. You can see there's more than one resource, and I did manage to keep this simple. This is it. So we're going to apply, if you haven't done already, all of those. This line actually, that's bad, sorry. I will excise that from the README after the playground because that's incorrect now. We don't override the region, we ask users to set it properly. Okay, if we've deployed everything right, and now I mention that, I should probably deploy my own ones, otherwise I'll be behind when we come to the end. Let's actually copy and paste those commands because it's really quick when you do that. Right click, paste, unchanged, configured. Do note that that says configured and not created. I don't remember the right words to describe why it's like that, but basically every time you apply this, it will respond with configured, not unchanged or created or et cetera, et cetera. We are done essentially with the platform engineer. And if we've done our job right, the application developer's job is going to be very easy. Foreshadowing. I'm going to quickly, what was I going to do? Get composite resource, oh, that's too much, sorry, too much text. Composite resource definitions, just to prove that they are there. Oh, good, right. Let's move on. In the audience right now, any particular questions or things you want to call out?
Yes.
Always.
So I noticed you mentioned that the XRDs have to be created first before the compositions. It has to propagate through. Is there a way by which you can actually kind of pull or check to see that they've been created before you apply the composition?
The question is, because XRDs need to be created before compositions, is there a way to check if they're ready, basically? And the answer is yes and no. It's very quick, unless there's a problem with your cluster. So if you deploy XRDs, it is usually, as you can see here, it would be the time between running one kubectl apply command, waiting for it to finish, and then running the second one. That's usually enough time on a quiet cluster. But again, you could run get composite resource definition, check for the ones that you created. Note that they have the same API group here, because I chose that to be what it is. That helps us later. And then just check if the output looks okay, right? If they haven't been deployed yet, or if they're not ready, it doesn't really matter when you deploy the compositions. You'll just get a warning saying, hey, actually, that's not really valid, and you can apply it again, and it will say, oh, actually, this time it's good, and then you're fine. It's not unsafe. Yeah. Any other questions? I don't suppose there's any questions on the chat that I can't see. I got a big shake of the head and a thumbs up. Oh, great. Thank you, chat. That's great. Okay. That was super confusing. I'm good. We're going to go up one level. Oh, we can't do that because I don't have the command. Let's look at this. Right. We're going to go all the way to section 2. The application developer. As a reminder, guess what's coming on the next page? As a reminder, we're going to request an S3 bucket and an RDS instance. That happens to be Postgres. We don't want to do any work. No, that's not what I mean. We don't want to really have the overhead of defining all of the stuff we just defined. We just want to get a database and an S3 bucket, right? Simple. If you click this link to claim resources, which is the first part. Oh, I'm sorry, that sucks. Well, we can just go into the folder, which is called, oh my goodness. Oh, I duplicated a line. I'm terribly sorry. I will fix that afterwards. We just go into application developer / claims, and there's a README here. Guess what? It's our favorite diagram. Hopefully this makes slightly more sense now, if not completely. So we've done both sides of this under the line. So we've done the edges. There are no resources in AWS right now that are relevant to us. We haven't created any. We've just made a template and a system that can build them for us, if everything goes well. What we're going to do now is we're going to make a claim. We're acting as this application. Understand that the application developer here might actually be a machine. It could be that the developer builds this functionality into their app to request new S3 buckets, and all that app does is talk to Kubernetes and say, hey, can I have a claim, please? And if it's deep in the Kubernetes system like that, it would be very, very natural for them to do that. Once we've created a claim, which is based on the composite resource definition, well, that's it, basically. Crossplane and Kubernetes will go away and create us a composite resource, another Crossplane object, and that will trigger the creation of real virtual resources, you know what I mean. Okay, so we've done the sides, we're now going to the top, we're going to come down. Importantly, I think I mentioned this before, all the other objects in this scenario are not namespaced, which is neat for platform engineering reasons. The claims are namespaced. I already talked about that. Sorry, I've bamboozled myself with my own writing there. While the structure of a claim is defined by the relevant XRD, parameters specified on claims are consumed via a composition to template resources in a composite resource. That's correct. It's right. I won't try and second guess it. So we're going to make a claim. It's as simple as making any Kubernetes resource. You've already done 1, 2, 3, 4, 5, 6, 7, about 7 of those today. Should be able to handle 2 more. There is a, okay, cool. We're going to come back to kubectl explain, where we're going to specifically ask for the Postgres parameters again. Or if that's not interesting, we can ask, still need to ask for parameters. We can ask for the S3 bucket, private bucket, again, unless you changed that name, in which case be very careful, the private bucket parameters. I've made this convention, this parameters object. If you choose not to, you will have a very busy bit of output here, because every field of the spec is a bit more than you need. Here you go. A bit more than most users would need. None of that is useful to you. And the parameters object doesn't detail its dependencies without passing the recursive flag, which doesn't give you enough information. I've decided that that convention, and it's one we're using in our internal platform. So you don't have to call it parameters. You can call it options, whatever you like. It's just a convenience thing to get an output that's useful for your end users. Knowing this, though, we can go and make a claim, no problem. I mean, I've made it very easy. We're going to take this and we're going to create a file. Now, because of a quirk of our infrastructure, apologies about this, what we're actually going to do is cd into the claims folder and touch claims.yaml. Once you do that, there will be a file here to edit. If you do it from this VS Code system, it will appear, but it will be owned by root, and you might not be able to do anything with it. If you get stuck that way, delete it from the editor and use that touch command to create it, and you should be good. If you're doing this much later at home, you won't have this problem. So we've made this claims file. We're going to paste in the information from our README there, and you might be able to see if you're keen-eyed that there are a bunch of missing fields. There's the name we need to decide on. You can give it whatever name you like because you're the end user and you get to decide. We also need to specify the Panda name. That needs to be your Panda name, which, if you're not aware, is the first part, with or without the word Panda, the first part of the URL for your terminal and for your editor. It's also displayed here. My password is not Victor. Please don't try to hack my instance. So we're going to fill those in. I'm going to call mine, oh, I don't know what I want to call mine. I need a name that's not the name you've used. Come on. You want me to call it Funny Panda? No, that's my Panda name. That's got to go here. That has to go here. Don't write Funny Panda on yours. You need to write your Panda name. I need a name for my objects. Andy. And Ant. Cool, thanks everyone. Okay. You can name these more sensible things. Please, if you're using this in production, don't name them Andy and Ant. I want to type less, so I'm going to call them really short names. Okay, once we've done that, can we guess what the next step is? I'm serious. Apply it, that's right. We're going to kubectl apply-f claims.yaml. If that is the name of your file, please apply the one you actually have. Okay, we create some claims. That was it. Thanks everyone for coming. No, there's more, sorry, there's more. Okay, we've created some resources, but that's not the end. We're going to go on to a section called troubleshooting. I'll give everyone a minute. You can pre-read a bit of this if you like. So this is, in my opinion, the best part. This is where we really get to know Crossplane and the resources we've created, and has really been the difference between, yeah, I kind of get this theoretical, applying some YAML files and defining stuff, and maybe it works or doesn't, to, oh, that's what it really made. Okay, I understand now. And this is going to come in handy, basically. So once again, we've created this thing, this claim, and beneath the surface of our app team concerns, I like that, we don't know if anything's really there. We know that the CRD exists, and we know that the composition exists because, we know that the CRD exists because it defined our claim, and our claim wouldn't have been created if that was wrong. We know that the composition exists because we made it a second ago, let's be honest. But our composite resources are, I don't know. Let's go find out. So, were our resources deployed like we expected? What can we do to discover them? If we've got some Kubernetes pros in the audience, again, they might just know this without thinking. It's built into the way we use Kubernetes already. If I can remember how to type the most basic command that we've run 8 times today already, then that would help. Okay, first of all, we're just going to run a get. We can't get claims, by the way. If that wasn't clear, if I didn't ram that point home enough already, claims is not a thing. Even though in the diagram it says claims, and everything I've been talking about, even the file name, is claims, They aren't called claim anywhere in Kubernetes at all. They are named with the thing we created. They are custom objects with the kind and the names that we defined. So we actually have to get, if we want to get them, we need to get something like private bucket. And that will list, you could of course write private buckets because we defined that there would be a plural word for private bucket called private buckets. That's it. There are, ooh, interesting. It's listed 2 things when they are not supposed, what did I do wrong? That's very interesting. They should not be both called private bucket. I've just misread the output. Good job. Thank you. Right, there are 2 buckets because this one is not to do with me, or not to do with our demo here. So private buckets, ant is the bucket we care about, and that will show just the one we need to get. Ready, false is interesting. We might have to come back to that. And we can also list our other object, which is post. I apologize for the length of this typing out with all the various capitals, but it's neat. PostgreSQL instance. I should have called it Postgres, I'm sorry. It's not called Ant. It's called Andy. Okay, that's also false. Huh, what does that mean? Okay. So, other things we can do. We can use Kubernetes other commands. We can use describe. Now, describe is great because what it is designed for is giving a kind of summary of human readable output, relatively human readable output. Let's describe the Postgres instance, and remember to put your name here. Double check if I haven't missed anything in our little thing here. So we're describing the Postgres instance. Cool. Lovely. This says there was, very important. Okay, the first thing we need to look at here, every single time you do a describe on a cross-plane resource that we've just created, on a claim or a composite resource or a managed resource that's below the composite resources, you should look here first. This has tripped me up a bunch of times, tripped other people up a bunch of times. I implore you, I guess, look at this first. So first of all, we can see reconcile success. That means that at some point when we created the object, Kubernetes understood it, or Crossplane understood it, and it went through the processing loop of like, okay, what objects do we need to create? Let's create these things, blah, blah, blah. Essentially, the Kubernetes side of this is good. Claim is waiting for composite resource to become ready. I'm going to bring the diagram back. So we're looking at this, and this thing is okay, but it's waiting for something. Like it's valid, but it's not. It's reporting that there's some problem. It might just be fine eventually, and that's unfortunate because it's not fine. Spoilers. So we're going to look here next. Sorry, here. I've highlighted too much. This one, resource ref, spec.resourceref. This is telling us all the details of the composite resource so that we can find it. You can do this programmatically. We're going to do it manually for now because it's useful to know. So we're going to add an X to Postgres instance, and then we're going to add this ID to the end so that it matches this, right? So it's X Postgres instance, PostgreSQL instance. Andy, in my case, and be careful because yours will definitely be different. In my case, it's this strange code. You will also have a 5-letter code. It will be incredibly shocking if it's the same code. So don't type it. Type your own. Oh boy. Here are a bunch of errors. What happened there? Reconcile error. Okay, that's fun because this isn't the error that I expected. Okay, interesting. So reconcile error is good. As I was saying, that reconcile complete, I can't remember the words it said, reconcile, scroll. Where did it say? Reconcile success meant that you can think of the Kubernetes side was good. Reconcile error is an indication that the Kubernetes side is not good, which I didn't intend, so there's probably a mistake in one of our files. Let's have a peek. It says the region in this, I've just picked a random event here. The spec.for provider region is required, but it was invalid. Okay, I know where to correct this. We can just go and fix it. The place we need to fix that is our audience. Any idea? RDS composition, correct. So we were looking at the RDS claim, and then we were looking at the RDS composite resource. Remember, that's the middle of the diagram. We're going to go across to the composite, well, across this side. It was on the diagram. I may as well bring it up again. So we looked at this, discovered that this was unhappy. It was unhappy in a Kubernetes kind of way. So I know that there's a problem with this composition, that we missed something here. So it's easily fixed. We're going to go down here and check what is in for provider. I think what's happened is, let's double check on here. Yeah, it's just missing. Okay, well, apologies. Right, what we need to do is drop a region into here. Okay. I can't make that easy to copy paste. Oh well. So this needs to be region EUST2. Please use EUST2. Make sure it's indented under for provider, and then we're going to have to go back a couple of steps to apply the RDS composition again, and then we're going to go and look at what is or isn't wrong with S3, troubleshoot that, and come back. And by the time we've come back, this should have given us some different output. So I'm going to save that. So inside RDS instance composition, RDS composition, look for provider, there's only one, and add region EUST2, like that. And here, we're going to have to CD all the way back up to 1C. You can find it, you don't have to do it in one step, you can find it slower than that, don't worry. And then we're going to go kubectl apply-f rds composition.yaml, enter. Okay, we've reconfigured the composition. We're going to move on for a minute and we're going to come back to it. I am going to check, while we're waiting for that for a second, in the original repo, if that needs fixing still, and then I'm going to make a note of it. Sorry, wrong folder. Nope, it's not. Great, okay, cool. Okay. In addition to that, come back to our claims. We need to understand what is or isn't going on with the S3 claim that we made. So where we described earlier, Postgres instance, in my case it's called Andy, instead of all that, we're going to describe a private bucket called Ant. Thank you. Audience, remembering my names is great. External memory. What do we got on this one? This says, reconcile success, claim is waiting for composite resource to become ready. Inside there, so we're going to describe X private bucket. It's not called Ant, it's called, in my case, again, got to be careful, Ant W, well, blah, 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 JXK. Again, straight to the status. Don't look at the events first. It's tempting, but look at the status first. I promise you, you'll have a better time. So this says all of these resources are unready. All of them. Okay. Odd. Why? Well, let's go look at one. This time, we're not looking at X private bucket. We're looking at the specific ones up here. I'm going to pick the bucket because that seems the easiest. going to paste bucket in. It happens to also be called ant, the same name as your composite resource, and another ID, because they're all linked together that way. That's a neat convention. Everything is broken because we have API error access denied. Chances are somehow my bucket name is wrong. Do we have that same error in the audience? Oh, good. My bucket is, it's because I didn't name it the panda name. That's my fault. Okay, cool. I should know my own playground better than that. Brilliant. All right, so that's easy to fix. And you shouldn't have to do this unless you, I mean, if you did tell us to call it the panda name, and I forgot. Funny panda. Let's make this all funny panda. Is there a chance the IDS instance is a problem as well? I don't think there is. We're actually leave that one called Andy. I think it's only the bucket that does this. So we're going to change that. We're going to redeploy or reapply the claims from the claims folder. qctl apply -f claims. Pow pow. I've done this before and this is silly. So I've made a classic Kubernetes error there, if you're interested. What I've done is I've created two resources because I changed the name on one in a file, and the way that apply works is it doesn't know anything about the file itself. It only knows the resources by name. So I created ant, and I changed the file out from under it, and I created funny panda. It didn't try and rename ant to funny panda. You don't need to worry about that. That's my fault. It'll be fine. So that one, if we look at the correct resource now, describe private bucket. You can hear I need a drink again. Private bucket, funny. Ooh, funny panda. You can see that this one is waiting for composite resource to become ready. We need to check the composite resource. So it's add an X, then add the ID. What's the ID? Okay, what does this say? Right, this one says unready, all of them, because they are currently creating. There are no errors. So that is probably just our good old friend eventual consistency, and it's waiting for them all to be created. Probably a good time to, it's a good time to go back. But in case we do any more debugging, I'm going to reveal a cool secret thing. I did say there was a third CLI that I wasn't going to tell you about. If we pop back to the README here, the right to README, the troubleshooting one, we'll come back to this in a second. If your RDS instance is working and it's not broken like mine was, then expand this and have a look at it. But if it's not working and you need to do more debugging like I do, you can use the Crossplane CLI. That's right, there's a Crossplane CLI we installed for you, and it can tell us in one step all of that. Describe the top level, then find out the ID and describe the next level, then find out the ID and describe the next level. The reason the command is called beta is because it's quite new. The Crossplane CLI, by the way, does a bunch of other useful things, but they are very focused on testing and validating resources and exploring Crossplane. They're not really for the basic level. So let's just trace Postgres instance. What do we call it? Ant. Did I forget that that's the right name? Let's double check. It's called Andy. That's my fault for naming them very similar. Okay, so it still says reconcile error code 400. Oh, that's weird. I wonder what that could be. Let's describe. Oh, sorry, I cleared that out. But you can go straight to the instance because you can take this ID from here and describe it straight away. We don't have to dig through all those resources again. Describe. That paste doesn't work, sorry. Paste. Okay. Describe the instance. Oh, there's a bunch of stuff here. What's going on? Well, I said to check the status field first, so let's do that. Oh, right, create failed. Blah, 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 blah. And invalid instance class T3 micro. That's weird. Now, this is the trap that I built into the playground that's meant to be an error, not the other errors. This is meant to be here. What's going on, if you expand this answer section here, is we just chose the wrong instance class. It's an easy problem to create. I'm not going to do it for this demo, but we could quite easily, in our XRD, specify, don't follow along with this, sorry, you don't have to follow along with this. We could quite easily add to the instance size parameter that we specified here, something like this, which would let us specify db.t3 micro, db.t3 small, and we can control people's inputs that way and say like, no, those are not valid values. That would have saved us a lot of time here because it would have errored out at the at creation time of the claim. So if we create a claim and it doesn't have valid values according to the XRD, it just straight away, no, that's wrong, create a valid object, please. We wouldn't have had to go debugging. The application team wouldn't have had to call the platform engineering team. Not going to implement that now, it's just an FYI. That feature's pretty easy to add. So what we are going to do is just simply look at our claim, see that, yep, we did call it T3 micro, should have been db.t3 micro. By the way, I don't think anyone here in the audience spotted it, but if you spotted that when you were defining it, or you looked at that thinking, that doesn't seem right, then well done. Wrong instance size, created the right instance size. It's everyone's favorite command, we're going to apply it again. Apply-f claims.yaml, boom. Configured the Andy Postgres instance, and now I'm going to use that beta command to, combined with a watch. We're just going to watch that every 2 seconds until it's ready. We'll come back to it. Okay, right. That is almost it. Really, it is it. While everyone is waiting to see if their databases deploy, we've got some more time for questions. We've got questions in the chat. Please write in. If you want to send them on a stamped addressed postcard, you can't. Sorry. Questions?
Can we see the instances in AWS?
Can you see the instances in AWS? Right. I don't think we have AWS console access for all our attendees. You essentially are asking, Michael, can you prove that what you've just shown us did anything? Fair question. Fair question. We can AWS S3LS, we should be able to, S3LS. If we grep for, in my case, funny panda, no output, don't do this to me. That should have been working. I couldn't refuse though. Private bucket, that one's called funny panda. Did it still not work? Oh, okay. Well, we can go and investigate that, I suppose. We are running out of time here, though. Let's kubectl describe. I can't type. That's what's happening. No, in this case, we're trying to look at the resource specifically, and the resource kind is bucket, not private bucket. Private bucket's the claim type. So we're, sorry to bring this out again, we are down here, not up here. The question was, well, should that have been private bucket? Sorry. What does this say? This says the existing secret is not controlled by UID, blah, blah, blah. Someone says it's possibly because we have another claim that exists that is too closely similar to the one that I created, in which case it's probably my problem with our composition is not designed to handle loads and loads of buckets with the same claims, which it should have been. That's my fault. What I can do is kubectl delete, well, no, not bucket, delete private bucket demo deleted. It might not, again, with our good old friend eventual consistency, this might not very quickly work. So we might have to wait for that one. We can go back to beta tracing the Postgres instance, and if that's ready, then we might have to stop. Postgres instances, RDS instances sometimes take quite a long time to create those. So this says it's creating. Have another little quick look. That's not going to work. There we go. Invalid instance class T3 micro. Okay, no. So this one says invalid instance class, but we definitely updated that.
It is fine. It's successfully created.
These guys are saying that it's actually. Sorry, these guys at the back are saying they're looking at the console and they promise that it is correct. It is correctly created. I don't know if maybe it wasn't found by my S3 command for some reason.
This is not yes.
Oh, sorry, this is an RDS. Oh, okay. So the listing, Amate asked this earlier. Listing RDS instances is a bit awkward on the console. You should be able to do something like RDS describe DB instances, and it will, if there's at least one, it will output a lot of text. So there is a DB T3 micro called Funny Panda. Yay! It did create. This is a genuine. I wouldn't say it's an issue, but it's a frustration I have with Crossplane, that we can look at things and. Now it's created, of course, now I've said that. It takes a long time to create stuff. It's not all instant. So if you need something done right now, because an attendee of your presentation has just said, hey, prove it, and it isn't there, you can't make it faster. You just have to wait. So it's there. I think there might still be a problem with my bucket. It's probably because I've created too many, because this is my messy demo instance and not your nice clean ones. Is your bucket okay? Okay, the audience says the bucket's okay, so hopefully yours are all right as well. There's one more thing I'd like you to do. It's not really a learning thing, although you do get to run a kubectl command that's not apply. Can you kubectl delete your claims? Eventually, that should delete some resources for us and will make our cleanup a bit easier. If you're still playing with it, feel free. I don't know if how long the instances live for after the playground, remind me? About midnight tonight, they will be destroyed forever. So if you want to steal anything from there, or steal, I mean, extract your work, or save anything, or you just want to practice more, you're welcome to do that. One last chance for questions. Please don't torpedo the last second of the presentation. No, you ask a question, just not. Okay. Is there anything in the chat?
Someone has successfully been able to create it in the chat.
Thank you very much. Okay, that is going to be everything. Thank you so much for attending DevOps Playground. So closing out, or is this it? Sweet. Thank you, everyone.